They say the universe is vast, cold, and silent. But what if? It's hiding secrets far beyond our imagination, from the question of life on Mars to the possibility of parallel universes, from the eerie silence of extraterrestrial civilizations to the dark enigma of black holes. These are the questions that keep even the brightest minds awake at night. Why haven't we found aliens? What's really on the dark side of the moon? And could our consciousness be something more than just brain activity? In this video, we're diving deep into the 10 most mysterious cosmic questions humanity has ever faced. Questions that challenge science, steer philosophy, and haunt our dreams. If this video sparks a thought, a theory, or even a wild guess, don't hesitate to leave a comment below. Your voice might unlock the next great mystery. And if you're enjoying the journey into the unknown, hit that subscribe button, it's free. And who knows, it might just bring you luck, fortune, and a touch of cosmic wisdom. Because in a universe this strange, nothing is ever just a coincidence. Let's begin. One life on Mars. Did it ever exist? Mars, a red, frozen desert that's been dead for billions of years, or has it? What if this planet once pulsed with life? Its rivers teeming, its skies alive. The question isn't just whether life existed on Mars, but whether it's still out there, hiding. Let's cut to the chase and unpack the evidence, the theories, and the stakes of this cosmic puzzle. First, the ground tells a story. Mars isn't just rocks and dust, it's a graveyard of ancient water. Val Marineris, a canyon stretching 500 miles, bears scars of rushing floods. Dried riverbeds, like those in Elysium Planitia, twist across the surface, their banks hinting at lakes or seas. Radar from orbiters like Mars Express has mapped subsurface channels, suggesting groundwater lingered long after the surface dried up. These aren't guesses. Sediment layers in places like Gale Crater, studied by the Curiosity rover, confirm water flowed for millions of years. Hematite and clay minerals, which only form in wet conditions, litter the landscape. Mars wasn't just damp, it was soaked. And where there's water, life often follows. Now, let's talk hard evidence from our robotic explorers. The Curiosity rover, poking around since 2012, sniffed out methane in Gale Crater's air. On Earth, methane often comes from microbes or geological activity. On Mars, it spikes mysteriously, then vanishes, as if something's producing it. Could it be volcanic? Sure, but Mars's volcanoes are mostly dormant. Could it be life? That's the tantalizing maybe. Curiosity also found sulfates and organic compounds, carbon-based molecules that are life's building blocks. These aren't fossils, but they're ingredients. Meanwhile, the Perseverance rover, scouring Jezero crater since 2021, is collecting samples from a former lakebed. Those rocks, set to return to Earth in the 2030s, might hold the smoking gun proof of ancient biology. Then there's the wildcard meteorites. In 1984, a rock called ALH 84001 blasted from Mars to Antarctica, stunned scientists under electron microscopes. It revealed tiny, worm-like structures, about 100 nanometers long, resembling fossilized bacteria. Skeptics call them mineral quirks, formed by chemistry, not life. But defenders point out their eerie similarity to Earth's microfossils. Other Martian meteorites, like Nakla, contain organic carbon. These rocks, flown across space, are clues that Mars might have hosted microbes, or at least the chemistry to support them. The debate's fierce, but the possibility is electrifying. So, what's the big picture? Let's test some hypotheses. Theory 1, Mars was Earth 2. Ling, 4 billion years ago. It had a magnetic field, shielding it from solar winds. Rivers ran, clouds drifted, maybe even simple life. Think algae-like microbes thrived in shallow pools, but the magnetic field died. Solar radiation stripped the atmosphere, and the water boiled away or froze. If life existed, it went extinct, leaving traces in the rocks. Theory 2, life adapted. Some microbes might have burrowed underground, surviving in briny aquifers or ice pockets. On Earth, extremophiles thrive in Antarctic ice or deep-sea vents. Why not Mars? The methane spikes could be their breath, seeping up, Theory 3: Mars was always sterile. The water and minerals were there, but life never sparked. This one's grim, but it's possible. Let's analyze these. The Earth-like Mars theory holds water literally. The geological record, from river deltas to lake beds, screams habitability. Organic compounds and methane bolster the case. But extinction seems likely. Without an atmosphere, surface life would have been scorched. The adaptation theory is trickier. Subsurface life is plausible. Earth's deep biosphere proves it, but detecting it is tough. Veds need drills, like the ExoMars rovers, to probe kilometers deep. The sterile Mars theory, it's the skeptic's fallback, but it struggles against the mounting evidence water. Minerals. Organics. Occam's razor leans toward life, past or present. What makes this gripping isn't just the science, it's the implications. If Mars had life, it means the universe might be teeming with it. 2 planets in one solar system with biology, that's no fluke, it's a pattern. But if Mars is dead, it's a warning. Earth's magnetic field and atmosphere aren't eternal. Mars shows what happens when a planet's defenses fail. Either way, the search is urgent. Perseverance's samples could confirm microfossils. Future missions, like China's Tianwen-3, might drill for living microbes. Every datum pulls us closer to an answer. So, is life on Mars extinct, hiding, or a mirage? The red planet's playing coy, but we're relentless. Rovers Kralv, orbiters scan, and soon, humans might walk its surface. If life's there, we'll find it in a fossil, a gas plume, or a salty spring. If not, we'll learn why, and protect our own world from the same fate. Mars isn't just a planet, it's a mirror. A riddle. Ader. The truth is out there, and we're closing in. 2. The dark side of the moon. Just rocks, or something more. The moon, our closest cosmic neighbor, glowing softly in the night sky. But there's a side we never see, a shadowy, half-cloaked in mystery. The far side of the moon, forever turned away from Earth, has fueled wild theories and whispered secrets for centuries. Is it just a barren wasteland of rock, or does it hide something stranger? Let's rip the veil off this enigma and dig into what's really out there. Why don't we ever see this hidden face? It's not magic, it's physics. The moon is tidally locked to Earth, meaning its rotation matches its orbit, keeping one side always facing us. This lock formed billions of years ago as Earth's gravity slowed the moon's spin. The far side isn't dark, it gets just as much sunlight as the near side. But it's invisible from our planet, a blind spot in the sky. That invisibility breeds questions. What's there, craters and dust? Or something we're not meant to see? Let's start with the wild stuff, the hypotheses that make your skin crawl. For decades, fringe theorists have claimed the far side is a cosmic hideout, alien bases, they say, tucked in craters, humming with activity, UFOs zipping through the shadows. Some even whisper of artificial structures, pyramids, towers, or grids built by intelligences not of this world. These ideas sound like sci-fi, but they persist, fueled by the far side's inaccessibility. In the 1960s, Soviet and American astronauts reported odd radio signals during lunar missions, dubbed moon music by Apollo crews. Static, sure, but to conspiracy buffs, it's proof of extraterrestrial chatter. No hard evidence backs these claims, yet the far side's isolation makes them hard to dismiss outright. What if something's watching from those silent planes now? Let's ground ourselves with what we've actually seen. Spacecraft have pierced the far side's secrecy. In 1959, the Soviet Luna 3 probe snapped the first grainy photos, revealing a rugged, crater-pocked landscape. No alien cities, just rock. Fast forward to 2019, when China's Chang'e 4 mission made history by landing in the von Karman crater. Its rover, U2-2, beamed back high-res images of a stark, gray desert basalt plains, deep scars, and the South Pole Aitken Basin, a 1.6 mile wide impact zone. NASA's Lunar Reconnaissance Orbiter LRO, circling since 2009, has mapped the far side in obsessive detail. These images show differences. The far side has fewer Maria dark lava plains than the near side, and its crust is thicker, hinting at a unique geological past. But Anomalies Chang'e -4 found a strange gel-like substance in 2020, later identified as melted rock. LRO's cameras have caught odd shapes, boulders, or shadows, but nothing clearly artificial. Still, every pixel gets scrutinized by amateur sleuths hunting for that one weird thing that doesn't fit. Then there's the lore. Ancient myths paint the moon as a goddess, a trickster, ora portal. Modern tales are wilder. In the 1970s, a hoax book, We Never Went to the Moon, claimed the far side hid NASA's staged landings. Ufologists point to blurry Apollo photos, swearing they show craft or domes. A 1990s tabloid screamed about a secret moon base spotted by psychics. These stories thrive because the far side is a blank canvas for imagination. Even credible voices like Fomer U.S. Military officials in recent UFO hearings hint at non-human tech in our skies, nudging the question, could the moon be a staging ground? No proof, but the rumors keep swirling. So, what's the truth? Let's break it down. The alien base theory is thin. Decades of probes show no clear signs of life or structures. Radio signals, likely solar flares or equipment glitches. Odd shapes in photos, geology, not architecture. But the far side's unique geology is intriguing. Its thicker crust and massive basins suggest a violent history, maybe tied to a cataclysmic impact. Could that have buried evidence of something fossils, tech, or weirder, unlikely, but not impossible? Another angle, the far side's isolation makes it a perfect lab for future human bases. Shielded from Earth's radio noise, China's planning more missions. NASA's Artemis program eyes the moon's south pole. If secrets exist, they won't stay buried long. Here's the kicker. The far side doesn't need aliens to be profound. It's a time capsule, untouched by Earth's gaze, holding clues to the solar system's birth. Yet its mystery invites us to wonder, if something's hidden by nature or design, we're closer than ever to finding it. Rovers travel, satellites snap, and soon, boots will tread those craters. The far side might be just rock, or it might rewrite history. Either way, it's calling. Are we ready to answer? 3. Why haven't we contacted alien civilizations? Yet the Fermi Paradox. The universe is screaming with possibility. 100 billion galaxies, each cradling billions of stars, trillions of planets. Some must harbor life microbes, civilizations. Minds like ours are stranger. The math says so, yet, when we point our telescopes to the stars, when we beam our signals into the void, we get nothing. Silence. This is the Fermi Paradox. If aliens are out there, where the hell are they? Let's tear into this cosmic riddle and face the answers. Some thrilling, some terrifying. Named after physicist Enrico Fermi, who tossed out this puzzle over lunch in 1950. The paradox is simple but brutal. The universe is 8 billion years old. Even at a snail's pace, an advanced civilization could colonize the galaxy in a few million years. So why no radio signals? No megastructures? No hello etched in starlight? Why does the cosmos feel like a ghost town? Let's unpack the leading theories, each a piece of this interstellar whodunit. First up, distance and difference. Space is big, mind-bogglingly big. The nearest star, Proxima Centauri, is 2 light-years away. Sending a signal that far, clear enough to be heard, is like whispering across an ocean. Maybe aliens are chatting, but their signals are too faint, scrambled by cosmic noise, or using tech we can't fathom. Think quantum pulses, not radio waves, or they're just too alien. Picture a species that thinks via magnetic fields or communicates through chemical clouds. We'd be as clueless as ants trying to decode Wi-Fi. This theory says they're out there, but we're shouting into the wrong void. Next, they came, they saw, they left. Some argue aliens visited Earth long ago, think ancient astronauts sparking myths of gods or leaving cryptic ruins. The Nazca lines, Stonehenge, or even tales of sky chariots in ancient texts fuel this idea. Maybe they probed our oceans, scanned our caves, then bailed when they found only grunting hominids. No evidence like, say, a buried spaceship backs this, but absence isn't proof. If they were here millions of years ago, erosion or plate tectonics could have erased their tracks. This hypothesis tantalizes but leans on speculation over fossils. Then there's the zoo hypothesis, and it's a doozy. Imagine aliens watching us right now, like scientists studying tigers in a preserve. They're advanced, cloaked, and silent, observing humanity as we bumble through wars and tweets. Why hide? Maybe they've got a prime directive against meddling. Or they're waiting for us to hit some cosmic benchmark, say, cracking fusion or ditching fossil fuels. Recent U.S. government reports on UFOs, like the 2021 Pentagon UAP task force, note unexplained aerial phenomena with no clear origin. Most are likely optics or drones, but a few defy physics as we know it. Could these be glimpses of our watchers? It's creepy, but it fits. They're here, just not taking our calls. Now, the grim one, the Great Filter. This theory says civilizations self-destruct before they can spread. Nuclear wars, climate collapse, or rogue AI could wipe out advanced societies faster than they can build starships. Look at us teetering on ecological and geopolitical brinks. Maybe the galaxy is littered with ruins of species that didn't make it. The chilling part, the filter could be ahead of us, meaning humanity's doomed to join the cosmic scrap heap. Or we've already passed it. Arare survivor. Either way, the silence might be a graveyard's hush. Finally, maybe we're just not ready. Our tech is young radio telescopes like SETI's Allen Array have only been listening since the 1960s. We scan a tiny sliver of the spectrum, assuming aliens use signals we'd recognize. The WOW signal, a 1977 blip that screamed not natural, never repeated. Maybe it was a fluke, or maybe we missed the encore. Our brains, wired for Earth's logic, might not grasp an alien hello if it's encoded in gamma rays or gravitational waves. This theory stings the parties happening, but we don't have the invite. Let's weigh these. The difference idea holds water space is vast, and alien life could be bizarre, but with billions of planets, some should have stumbled into our tech range. The ancient visitors theory is fun but shaky. No artifacts. No, dice. The zoo hypothesis is unnerving and plausible. Those UAP reports keep it alive, but it assumes aliens care about us. The Great Filter is the scariest, backed by our own flirtations with extinction. Though it's grimly speculative, the we're not ready angle feels likely. We're cosmic toddlers, barely listening. My bet, a mix of distance, weirdness, and our own limits keeps the silence loud. Here's the gut punch. The paradox isn't just about aliens, it's about us. If we're alone, as the final theory dares to whisper, that's lonelier than any void. One planet, one shot at sentience, in a universe that doesn't care. But if they're out there hiding, extinct, or laughing at our primitive radios, it's a call to action. We need better tech, like China's fast telescope or NASA's upcoming X-ray observatories. To eavesdrop smarter, we need to survive our own Great Filter. To prove we're worth meeting, the Fermy Paradox isn't a dead end, it's a dare. So, where are they? Maybe too far, too strange, or too quiet. Maybe gone, or maybe staring at us through invisible scopes. The truth's out there, in the static between stars. Keep listening, because the scariest thing isn't that they're silent, it's that we might be the only ones shouting. 4. The origin of life, natural process, or intelligent design. A single molecule, lifeless, floating in a primordial puddle. Then, a spark motion, replication, life. 4 billion years ago, Earth went from barren rock to a planet teeming with organisms. But how was it a cosmic fluke, a chemical inevitability, or the work of a deliberate hand? The origin of life isn't just a question, it's the question, straddling science, philosophy, and the edge of the unknown. Let's dive into the theories, the evidence, and the fight to understand where we came from. Start with the leading scientific idea, the primordial soup. Picture Earth. Sand. 8 billion years ago, volcanoes spewing, oceans churning, lightning cracking through a toxic sky. In this cauldron, simple molecules like methane, ammonia, and water collided, energized by heat and electricity. Ova eons. They formed amino acids, the building blocks of proteins, then RNA, the blueprint of life. This soup theory, proposed by Alexander Oparin in the 1920s, says life emerged from natural chemistry. No miracles needed. It's elegant, grounded in the laws of physics, and suggests life could arise anywhere with the right conditions, maybe even on Mars or Europa. The best evidence for this comes from a lab in 1953. Stanley Miller and Harold Urey simulated Earth's early atmosphere in a glass flask. They mixed water, methane, ammonia, and hydrogen, zapped it with electric sparks to mimic lightning, and waited. Within days, the mix turned murky with amino acids, life's raw ingredients. Later experiments added sugars, lipids, even nucleotide bases, the components of DNA. Miller-Urey didn't create life, but it showed the soup could cook up the essentials. Critics argue the early atmosphere might have been different, less friendly to these reactions. But the experiment's core insight holds chemistry can bridge the gap from lifeless to living. Now, a wilder idea: panspermia. What if life didn't start on Earth but hitched a ride from space? This theory says microbes or organic molecules, tucked inside comets or meteorites, seeded our planet. Evidence: carbon-rich meteorites, like the Murchison stone that fell in Australia in 1969, carry amino acids and complex organics, some not found on Earth. Lab tests show microbes can survive space's vacuum and radiation, like the tardigrades that thrived on a 2007 shuttle experiment. Directed panspermia, a twist, posits an alien civilization sent life here intentionally. No proof. But the discovery of Martian meteorites with potential microfossils like ALH 84001 from your Mars outline keeps this idea alive. Panspermia doesn't solve the origin question. It just moves it to another planet, but it's a cosmic curveball. Then there's the counterpoint: intelligent design. Proponents argue life's complexity, say. A cell's molecular machinery, with its thousands of interlocking proteins, defies random assembly. A single protein folding correctly has odds akin to winning the lottery 1,000,000 times. The bacterial flagellum, a microscopic motor, is their poster child. Too intricate, they claim, to evolve without a purposeful blueprint. This view, rooted in thinkers like William Dembski, doesn't always invoke a deity but insists on a guiding intelligence. Scientists counter that evolution, given billions of years, can build complexity incrementally. Yet the debate persists, especially where data gaps like the leap from RNA to cells leave room for doubt. This clash isn't just science versus faith, it's a philosophical cage match. The soup and panspermia lean on testable mechanisms, but can't yet recreate life in a lab. Intelligent design offers an answer but lacks falsifiable evidence, leaning on inference over observation. Both sides grapple with limits. Science demands natural causes, yet the first spark remains elusive. Philosophy asks, can we even know the truth? The anthropic principle muddies things. We're here to ask because conditions allowed it. But does that imply design or luck? The deeper we dig, the more the question feels like chasing a shadow. Let's analyze the contenders. The primordial soup is the frontrunner, backed by Miller-Urey and geological clues like 3-5 billion-year-old stromatolite fossils, hinting at early microbes. It's mechanistic, repeatable, and fits a universe where chemistry reigns. Panspermia is plausible but sidesteps the core issue, requiring life to start somewhere else. It's supported by space-hardy molecules but lacks direct evidence of interstellar delivery. Intelligent design resonates emotionally. Life feels engineered but struggles scientifically. As complexity doesn't prove an intent. Evolution's track record, like the fossil record's gradual transitions, tilts against it. My take: the soup's the strongest bet, but panspermia is a dark horse. And design, while untestable, keeps us honest about what we don't know. Here's the rub. The origin of life isn't just a puzzle, it's a mirror. If chemistry alone sparked us, life might be common, echoing the Fermi Paradox's hope of alien neighbors. If panspermia is true, we're part of a cosmic web, seeded across stars. If design holds, we're not alone but crafted. With purpose or experiment, each answer reshapes who we are. Yet the question might outstrip us. Labs like those at MIT, synthesizing proto-shells, edge closer. But the final leap life from scratch eludes us. Maybe it's beyond our tools, or maybe our minds aren't built to grasp it. So, was life a cosmic accident, a stellar delivery, or a deliberate act? The truth lies in ancient rocks, distant comme, or perhaps a realm we can't yet touch. The scariest thought isn't that we'll never know, it's that the answer might redefine everything. Keep searching. The spark that started it all is still out there, waiting. 5 black holes. What's inside them? The universe is a riddle, a tapestry of secrets stitched in starlight and shadow, from the red sands of Mars to the hidden face of the moon, from the silent void where aliens might lurk to the spark of life itself, and deep into the abyss of black holes. Each mystery beckons us to ask what lies beyond. Let's embark on a journey through 5 cosmic enigmas, where science meets wonder, and the answers might change everything. First, Mars. Was it ever alive? Picture a planet soaked in rivers, its canyons like Valles Marineris carved by ancient floods. Curiosity's methane spikes and hematite deposits scream water was here, while the Martian meteorite ALH 84001, with its microbe-like fossils, whispers of life. Maybe Mars was Earth's twin, its seas teeming until its magnetic shield failed, leaving a red corpse, or perhaps microbes still hid in briny depths. The truth Perseverance's samples might tell us, but Mars dares us to keep digging. Now, the moon's far side, its unseen half, locked away by tidal forces, no dark abyss, just a cratered wasteland lit by the same sun. Yet, myths of alien bases persist, fueled by odd Apollo radio signals and blurry photos. China's Chang'e 4 rover found only rocks in Von Karman crater, and NASA's LRO maps show no domes. Still, the South Pole Aitken Basin scars hint at a unique past. Is it just geology, or a cosmic cover-up? The far side silence invites us to wonder what's it hiding. Then, the Fermi Paradox. Trillions of planets, yet no alien signal. Not even a cosmic postcard. Are they too far? Their tech too strange. Like signals we can't decode. Did they visit, leaving Stonehenge as a clue, then vanish? Or are they watching? Zookeepers to our cage. As 2021 Pentagon UFO reports suggest, the Great Filter Theory chills, maybe civilizations self-destruct, as we nearly have. The 1977 WOW signal teased us, but the void stays mute. The scariest thought we might be alone, shouting into nothingness. How did we even get here? The origin of life is a puzzle of cosmic stakes. The primordial soup theory says lightning and chemicals brewed amino acids, proven by Miller, Urey's 1953 flask of proto-life. Panspermia posits microbes rode comets, like the Murchison meteorite's organics. Intelligent design argues cells are too complex for chance, pointing to the bacterial flagellum's motor. Science leans on chemistry, but gaps like RNA to cell leaps fuel debate. Is life a fluke, a delivery, or a plan? The answer might lie in labs or stars, but it redefines our place. Finally, black holes, the universe's ultimate enigma. A black hole is a collapsed star, its gravity so fierce that light can't escape past the event horizon, where time slows to a crawl. Inside lies the singularity, a point of infinite density, zero size, where physics breaks. Or does it? Some theorize black holes are gateways to parallel universes, wormholes bending space-time. Others, like Jacob Bekenstein, say they store lost information, every particle's history on their horizon. Stephen Hawking's 1974 math shows they evaporate, leaking radiation until they vanish. Lab analogs, like sonic black holes in water, mimic this. Could black holes birth new universes, each a cosmic seed? The 2019 Event Horizon Telescope's image of M87's shadow proves they're real, but their hearts remain locked. These mysteries intertwine. Mars and panspermia link life spread. The moon's far side and Fermi's silence fuel alien speculation. Black holes might hold the universe's blueprints, even life's origin. Each question pushes us to the edge of knowing. The evidence: methane on Mars, meteorite fossils, UFO reports, Miller's flask. Hawking's math grounds us. But the unknowns pull us forward. Are we alone? Designed connected to new realities through cosmic voids, the universe doesn't answer easily. What's next? Rovers probe Mars. Artemis eyes the moon. SETI scans the stars. Labs chase life's spark. And telescopes hunt black hole secrets. Every step risks a truth. We're not ready for solitude. Purpose. Or a multiverse. The cosmos is a mirror, reflecting our curiosity and fragility. Mars warns of lost worlds. The moon of hidden truths. Fermi of silence. Life's origin of our roots. And black holes of reality's limits. Together, they dare us to keep asking, to survive our own filters, to reach beyond. So, stand at the edge of these mysteries. The red planet, the shadowed moon, the silent stars, the first cell, the dark abyss they're calling. The answers might be out there. In a rover's core, a radio blip, a labial, or a singularity's heart. Or maybe they're beyond us, locked in a cosmic vault. Keep looking. Because the universe isn't just a place, it's a question. And we're the ones meant to answer it. 6. The Real Doomsday. Can it be predicted? The universe hums with secrets, each a thread in a cosmic tapestry, from Mars' lost rivers to the moon's hidden face, from the silence of alien worlds to the spark of life, from black holes' abysses to the final fate of everything. Our questions drive us to the edge of existence. Let's journey through 6 mysteries, where science, wonder, and dread collide, chasing the truth of our place in the stars and the day it all might end. First, Mars. Did life once thrive there? Ancient riverbeds in Valles Marineris and methane spikes found by curiosity hint at a wet, vibrant past. The Martian meteorite, ALH 84001, with its fossil-like structures, teases that microbes swam in lost seas. Perhaps Mars was Earth's twin until its magnetic field collapsed. Or maybe life hides in subsurface brines. Perseverance's samples, due back in the 2030s, could crack this case. But Mars whispers keep searching. Next, the moon's far side, forever turned from Earth by tidal lock. Myths of alien bases swirl, fed by Apollo's strange radio hums. China's Chang'e 4 rover, landing in Von Karman crater in 2019, saw only basalt and craters, and NASA's LRO maps show no structures, yet the South Pole Aitken Basin scars hint at a unique history. Is it just rock? Or a cosmic secret? The far side silence dares us to look closer. Then, the Fermi Paradox. Trillions of planets, yet no alien signal. Are they too far? They're tech too alien. Like signals beyond our grasp. Did they visit, leaving clues in ancient myths, then leave, or do they watch us? As 2021 Pentagon UFO reports hint, the Great Filter suggests civilizations die out nukes. Climate, II. The 1977 WOW signal was a fleeting tease, but the cosmos stays mute. Are we alone? Screaming into the void. How did life begin? The primordial soup theory says lightning forged amino acids, proven by Miller, Urey's 1953 experiment. Panspermia claims life from the comets. Like the Murchison meteorite's organics, intelligent design sees cells' complexity like the bacterial flagellum as proof of intent. Science favors chemistry, but gaps in the RNA-to-cell leap fuel debate. Was life a fluke, a delivery, or a plan? The answer shapes our cosmic role. Black holes where reality frays, past the event horizon. Time stalls, and light vanishes. Inside, a singularity crushes matter to infinita density. Or are they wormholes to other universes? Jacob Bekenstein says they store lost information. Stephen Hawking's 1974 math shows they evaporate via radiation. The 2019 M87 black hole image proves they exist. But their core might birth new realities, a cosmic cycle beyond our reach. Finally, the end of everything. Can we predict the universe's last day? Science offers grim scenarios. The big freeze in 100 trillion years? Stars burn out, and expansion chills the cosmos to near absolute zero. The big crunch? Less likely. sees gravity collapse everything into a fiery singularity. The Big Rip, driven by dark energy, could tear atoms apart in 22 billion years. Quantum cosmology models, like those from Andre Linde, map these fates, but dark energy's mystery clouds precision. Ancient prophecies, Mayan 2012. Nostradamus guessed dates but flopped. Today, nukes or bioweapons loom as self-made apocalypses. A 2023 Oxford study estimates a 1 in -6 chance of human extinction by 2100 via tech. The end might not roar but creep, unnoticed. In a silent cosmos, these mysteries weave a single thread. Mars and panspermia tie life spread. The moon and Fermi fuel alien dreams. Black holes in the end hint at cosmic cycles. Life's origin asks why we're here. Evidence methane. Chang'e Rocks. UFOs. Miller's flask. Mochenta y Siete's shadow. Linda's math grounds us, but unknowns pull us forward. Are we alone? Designed doomed. Each question mirrors the next. A cosmic echo. The stakes are high. Mars warns of fragile worlds. The moon, of hidden truths. Fermi, of solitude, life's origin, and of purpose. Black holes, of reality's edge. The end, of time's limit. Rovers scour Mars. Artemis eyes the moon. SETI listens. Labs chase life's spark. Telescopes probe black holes. And AI models cosmic fates. Each step risks a truth solitude, intent, or oblivion that could reshape us. Stand at this crossroads. The red planet, shadowed moon, silent stars, first cell, dark abyss, and final hour call-out. Answers hide in rover cores, radio blips, labvials, telescope lens, or equations, or they're beyond us. Locked in a cosmic vault, the end might come in eons or tomorrow. Loud or quiet, keep asking. The universe isn't just a place, it's a countdown, and we're racing to understand before the clock stops. 7. What is the shape of the universe? The universe isn't just vast, it has a shape, a structure that defines its past and future. Is it a flat sheet stretching to infinity, a curved sphere folding back on itself, or a wild, looping enigma? This isn't sci-fi, it's cosmology's deepest puzzle. The shape of the universe dictates whether it expands forever, collapses, or traps us in a cosmic maze. Let's plunge into the math, the measurements, and the mind-bending possibilities to uncover what the cosmos looks like and where it ends. Picture the universe as a giant canvas. Scientists propose 3 main shapes, each with its own destiny. First, a flat universe infinite, like a cosmic tabletop, expanding forever but slowing as it goes. Second, a spherical universe closed, like a balloon, where gravity could one day pull it back into a big crunch. Third, a saddle-shaped universe open, hyperbolic, stretching faster and faster into eternity. These aren't guesses, they come from Einstein's general relativity, which ties geometry to gravity. The flat model fits best with what we see, but the others lurk as possibilities, each reshaping our fate. How do we measure this? The key is the cosmic microwave background, CMB, the universe's baby photo, formed 0 years after the Big Bang. This faint glow, mapped by satellites like NASA's WMAP and ESA's Planck, shows tiny temperature ripples, clues to the universe's curvature. If the CMB's patterns are undistorted, the universe is flat. If they're magnified or shrunken, it's curved. Planck's 2018 data pegs the universe as flat to within 0, fear percent error, with a density parameter omega near 1, a hair over un, and it's spherical, a hair under. It's saddle-shaped. So far, flatness wins, but the margin's tight, and new telescopes, like the Simons Observatory, are sharpening the view. Let's dig into the flat model. A flat universe expands forever, driven by dark energy, which makes up 68% of the cosmos. Stars burn out, galaxies drift apart, and in 100 trillion years, it's a cold, dark void, the big freeze from our end-of-universe outline. Observations of supernovae, like those studied by Saul Perlmutter in 1998, confirm this accelerating expansion. But flat doesn't mean simpler. A flat universe could be infinite with no edge, or finite but unbounded, like a cosmic video game where you loop back to the start. The Planck data leans infinite, but we can't rule out a torus, a donut-like shape where space wraps in loops. Now, the spherical model. If the universe is a closed sphere, its gravity could slow expansion, maybe reverse it into a collapse. Light traveling in a spherical universe would curve, potentially letting us see the same galaxy from different angles. No such repeats show up in CMB maps, but the idea is not dead. A 2019 study by Eleonora Di Valentino suggested slight CMB anomalies hinting at a closed shape. Though most cosmologists remain skeptical, a spherical universe ties to the Big Crunch, a fiery end where everything implodes, possibly rebounding into a new Big Bang, a cycle echoing black hole theories from our earlier script. The saddle shape, or hyperbolic universe, is the wild card. Here, space curves outward, like a cosmic Pringle, and dark energy rips it apart faster than in a flat model. This leads to the Big Rip, where in 22 billion years, galaxies, stars, even atoms shred under accelerating expansion. The CMB's flatness makes this less likely, but models like those from Andre Linde's chaotic inflation keep it in play. A saddle universe is open, infinite, and chaotic, with no boundaries but endless divergence. Then there's a trippier idea, the multiverse bubble. Imagine our universe as one bubble in a frothy sea of universes, each with its own shape and laws. This comes from string theory and inflation, where quantum fluctuations spawn pocket universes. Our bubble might be flat, but others could be spherical or saddle-shaped. The 2020 work of Alan Guth supports this, suggesting our universe's flatness is a local quirk. No direct evidence yet, but CMB anomalies or gravitational wave detections could hint at bubble collisions. This model makes our universe a mere speck in a grander, unknowable whole. So, what's the verdict? The flat model leads, backed by Planck's CMB precision and supernova data. Spherical and saddle shapes trail, needing strong evidence. While the multiverse bubble is speculative but tantalizing, the catch measuring curvature is like mapping an ocean from a rowboat. We're limited by light speed, and the universe's 93 billion light-year observable diameter. If it's finite, what's beyond an edge? A void, or a loop? The CMB suggests no boundary, but our tools can't see far enough to be sure. This mystery echoes our series. Mars's life hints at cosmic commonality. The moon's far side, at hidden realms, Fermi's silence, at our isolation, life's origin, at our roots, black holes, and at reality's limits, the end, at times close. The universe's shape ties them all. Its geometry sets the stage for life. Aliens and doom. If it's flat and infinite, life might be everywhere. If spherical, we're in a cosmic cage. If a bubble, we're one of many. Stand at this edge. The CMBs glow, supernovae flicker, and equations of Einstein and Guth are our guides. But the universe's shape eludes us. Is there a boundary? A wall? Or just more space future scopes? Like the Vera Rubin Observatory, might refine the answer. The cosmos isn't just a place, it's a form, and its contours hold our story. Keep staring. The shape of everything is out there, waiting to be seen. 8. Why do dark matter and dark energy make up 95% of the universe, yet remain invisible? The universe is a shadow play, and we're only seeing the flickers. Just 5% of its stars, planets. Us is visible, the rest, a staggering 95%, is dark matter and dark energy, invisible forces that shape everything, yet dodge our gaze. They hold galaxies together, push the cosmos apart, and mock our best tools. Why can't we see what dominates existence? Let's chase this mystery, from galactic glue to cosmic accelerators, and ask, are we alone in missing the universe's true masters? Dark matter is the unseen scaffold of the cosmos. It exerts gravity, knitting galaxies into clusters, keeping them from flying apart. Without it, the Milky Way would unravel like a dropped spool of thread. In the 1930s, Fritz Zwicky noticed galaxy clusters moving too fast for their visible mass to explain something heavy, invisible, was at work. Later, Vera Rubin's 1970s studies of galactic rotation curves showed stars at galaxy edges, orbiting as fast as those near the center, defying Newton. Dark matter, about 27% of the universe, fills the gaps. It's not stars, gas, or dust. It's something else. Cloaked, pulling strings we can't see. Dark energy, roughly 68% of the universe, is even stranger. It's the force driving the cosmos to expand faster every second. In 1998, Saul Perlmutter and Adam Reyes studied distant supernovae and found them dimmer than expected, meaning the universe's growth is accelerating, not slowing. Dark energy, a mysterious pressure, counteracts gravity, stretching space like an inflating balloon. Einstein's cosmological constant, once a fudge factor, might be dark energy's math, but we don't know its source. It's not matter, not light, it's a cosmic push, reshaping the universe's fate, tying to the Big Rip or Big Freeze from our end-of-universe outline. Why are they invisible? Simple, they don't play with light. Dark matter doesn't emit, absorb, or reflect electromagnetic waves. No glow, no shadow. It interacts via gravity, maybe the weak nuclear force, but not light's playground. Dark energy is even slipperier, only detectable through its effect on expansion. Imagine trying to spot a ghost that only nudges furniture. You feel the push, but the source is gone. This invisibility isn't absence, it's a property. The cosmic microwave background CMB, mapped by Planck in 2018, shows dark matter's gravitational fingerprints in early universe ripples, supernova data, and galaxy surveys. Like the Dark Energy Survey, confirm dark energy's relentless drive. They're real, just maddeningly shy. Scientists are hunting these phantoms. At CERN's Large Hadron Collider, physicists smash protons to spawn hypothetical dark matter particles, like WIMPs, weakly interacting massive particles. No dice yet. But the search refines our models. Underground detectors, like the Lux Zeppelin experiment in South Dakota, use liquid xenon to catch WIMPs bumping atoms. A 2020 run saw nothing, but upgrades push deeper. For dark energy, the Euclid telescope, launched in 2023, maps galaxy distributions to trace expansion's history. These efforts, from particle colliders to space scopes, are like fishing in a pitch-black ocean slow, but closing in. If WIMPs or Axions, another dark matter candidate, show up, we'll rewrite physics. If dark energy's nature cracks, we'll predict the universe's endgame. Let's analyze the stakes. Dark matter's gravity shaped the universe's skeleton, as seen in CMB patterns and galaxy webs. Without it, no galaxies, no stars, no us life's origin. From our earlier outline, depends on it. Dark energy sets the cosmos's tempo, deciding between a frozen or shredded fate, linking to the shape of the universe's flatness. Their invisibility challenges our tools, not their reality. Could they be exotic particles, fields, or flaws in Einstein's equations? Modified gravity theories, like Mund, try to ditch dark matter, but fail against CMB data. The standard model WIMPs for dark matter, a cosmological constant for dark energy, leads, but gaps keep alternatives alive. This mystery echoes our series. Mars's lost life needed dark matter's galactic cradle. The moon's far side hides no aliens. Maybe because dark energy spaces them out. Fermi's silence might stem from dark energy's vast gaps. Life's spark relied on dark matter's structure. Black holes bend under dark matter's pull. The universe's end hinges on dark energy's push. Its flat shape aligns with dark energy's dominance. These forces aren't just background, they're the stage for every cosmic question. Now, the wild thought, what if we're not alone in missing them? Your Gorimo suggests other species, if they exist, might also squint at the dark. Imagine an alien Fermy Paradox, where civilizations, blind to 95% of reality, never connect across dark energy's voids, or maybe advanced beings see dark matter, wielding it like we do electricity, laughing at our crude detectors. This flips the script. Our ignorance might be universal, or a phase we'll outgrow. The Large Synoptic Survey Telescope, starting in 2025, could spot dark matter's gravitational lensing, inching us closer. Stand in this shadow. Dark matter binds. Dark energy repels. Yet both elude us. CERN's collisions. Lux's silence. Euclid's maps are our torches. But the dark stays dark. Is there a veil we can't lift? Or a truth too vast? The universe is 95% enigma, and we're the specks chasing its secrets. Keep hunting. What we can't see isn't just out there, it's everything. 9 do parallel universes really exist? What if every choice you make splits reality? Turn left, and a U turns right, living in a parallel universe where everything's just a little different. The idea of multiple universes isn't just wild speculation. It's a serious question in physics, philosophy, and even our deepest intuitions. Could there be countless realities, each a variation of our own, running alongside us? Let's plunge into the science, the experiments, and the eerie possibilities to ask, do parallel universes exist? And are they closer than we think? The multiverse concept comes in several flavors. First, the quantum multiverse, rooted in the many worlds interpretation of quantum mechanics. Proposed by Hugh Everett in 1957. It says every quantum event, like an electron's spin, splits the universe into branches. One for each outcome. You're in one branch. Another, you exist in another. Second, the bubble multiverse. From cosmic inflation, Alan Guth's 1980s work suggests our universe is one bubble in a frothy sea of universes, each with unique laws, echoing our shape of the universe outline. Third, the mathematical multiverse, where every possible configuration of physics exists, somewhere. These models, from quantum to cosmic, paint a reality where our universe is just one of many. The double-slit experiment is a key clue. Fire electrons through 2 slits, and they form an interference pattern, as if each electron passes through both slits simultaneously. Observe which slit they choose, and the pattern vanishes. They act like particles. Quantum mechanics says they exist in multiple states until measured. The many worlds view takes this further. Each outcome, slit A or B, creates a new universe. In 2019, MIT's quantum interference experiments with molecules confirmed this weirdness at larger scales. It's not proof of parallel universes, but it shows reality can split, hinting at worlds where different choices play out. String theory adds another layer. It posits 11 dimensions beyond our 3D space and time, curled into tiny loops. In 1995, Edward Witten's M-theory unified string models, suggesting our universe is a 4D brain floating in a higher dimensional space. Other brains, with their own physics, could be parallel universes, mere Planck lengths away but unreachable. Collisions between brains might leave traces in the cosmic microwave background, CMB. A 2010 study by Stephen Feeney found CMB anomalies that could hint at such collisions, though skeptics call them statistical flukes. String theory's math is elegant but unproven, yet it opens a door to realities we can't touch. Then there's the weird stuff, folklore and glitches, ancient myths, like the Norse Yggdrasil or Hindu Puranas, describe multiple worlds. Modern tales of reality glitches flood forums. People recall events that never happened, like the Mandela effect, where many swear Nelson Mandela died in the 1980s. In 2023, a viral X post described a woman slipping into a world where her house was slightly wrong. Different paint, missing keys, déjà vu, vivid dreams, or gut feelings might be echoes of other selves. As your gut suggests, no hard evidence. But these stories resonate, hinting at a multiverse leaking into our minds. Let's weigh the case. The quantum multiverse is compelling, double slit, and quantum entanglement confirmed by 2022. Nobel-winning experiments show reality's multiplicity, but many worlds is untestable. We can't visit other branches. The bubble multiverse fits inflation, backed by CMB flatness from Planck 2018. But bubble collisions remain speculative. String theory's 11 dimensions are mathematically sound but lack empirical proof. Glitches and myths intriguing, but likely psychological. The strongest hint is quantum weirdness, suggesting reality might fork. Skeptics argue a single universe is simpler, per Occam's razor. But simplicity doesn't rule out multiplicity. This ties to our series. Parallel universes could explain Fermi's silence. Aliens live in other branches or bubbles. But our Fermi outline, they might host life's origin, with panspermia crossing brains. Black holes, as wormholes, could link universes, per our black hole script. Dark energies push, shaping our flat universe, might vary in other bubbles. The universe's end, big rip or freeze, could differ across realities. If parallel universes exist, they're the ultimate context for every cosmic question. The stakes are dizzying. If many worlds is true, every choice spawns a new you, living every possibility. Bubble universes mean our laws of physics are local, not universal. String theory's brains suggest realities inches away, unseen. If dreams or glitches are cross-universe signals, our minds might bridge realities. Testing this is tough quantum experiments, like those at CERN's Future Circular Collider, or CMB scans by the Simons Observatory. Might find clues, but we're stuck in our slice, peering through math and mystery. Stand at this fork, the double slits waves, string theory's dimensions, and your own fleeting hunches hint at worlds beyond our memories, echoes of other lives. Do dreams glimpse other realities? The universe might be one, or it might be legion. Keep probing through equations, telescopes, or the quiet of your own mind. The multiverse isn't just out there. It might be you, multiplied, forever. 10 human consciousness, just brain activity or something more. What does it mean to know you exist? That fleeting I am flickering in your mind. Is it just brain cells firing? Or something deeper? Something science can't touch. Consciousness, the awareness of self and world, is our most intimate mystery. Is it a byproduct of neurons, a cosmic dimension, or a bridge to the soul? Let's dive into the theories, experiments, and wild ideas to chase the essence of what makes us us. And ask, is consciousness the key to the universe itself? Start with the mainstream view. Consciousness is the brain's handiwork. Neuroscientists like Christoph Koch argue it's an emergent property of neural networks, 100 billion neurons, a quadrillion synapses, churning data into thoughts, feelings, and selfhood. Brain scans, like fMRI studies from 2020 at MIT, show specific regions, like the prefrontal cortex, light up during self-awareness tasks. Damage the brain, say, in the thalamus, and consciousness dims. Essaying in coma patients. This materialist view says your eye is a biological machine, no magic needed. But it stumbles on the hard problem of consciousness, coined by David Chalmers. Why do raw signals feel like joy, pain, or the smell of rain? No equation explains that spark. Now, a wilder idea: consciousness as a separate dimension. Philosophers like Giulio Tononi propose integrated information theory, IIT, suggesting consciousness isn't just brain activity but a fundamental property of complex systems, measurable as phi. In this view, consciousness exists beyond neurons, perhaps as a cosmic field or dimension, like space or time. Some, like Roger Penrose, tie it to quantum mechanics, arguing it's a non-computational process rooted in subatomic realms. This echoes our parallel universes outline, where quantum splits hint at multiple realities. If consciousness is dimensional, it might link us to other planes or even the universe's own awareness. The question, who am I, cuts deeper. Self-awareness separates us from rocks, maybe from AI. Studies, like Elizabeth Loftus's 1990s false memory experiments, show the brain can recall events that never happened, planting fake pasts with suggestion. In 2023, Stanford's neural implants let paralyzed patients speak via thought, decoding intent from brainwaves. AI, like large language models, mimics human chat but lacks the feeling of existence. These experiments reveal consciousness as fluid, manipulable, yet elusive. Your eye is real but slippery, raising doubts about its neural roots alone. Quantum consciousness, a fringe but tantalizing theory. Penrose and Stuart Hameroff's OR model, orchestrated objective reduction, suggests consciousness arises in microtubules, tiny structures in neurons where quantum superpositions collapse, creating moments of awareness. A 2022 study at Caltech found quantum-like effects in brain proteins. Though not conclusive, This theory links to the cosmos. If quantum processes drive consciousness, we're tied to the universe's subatomic fabric, maybe even its origins, per our life's origin outline. Critics call it speculative. Quantum effects in warm, wet brains seem unlikely, yet it offers a bridge to the metaphysical, suggesting consciousness isn't just local but universal. Let's weigh these. The neural model dominates fMRI data. Brain injury studies and AI mimicry point to the brain as the seat of awareness. But the hard problem looms. No scan explains why you feel. IIT's dimensional view is elegant, quantifying consciousness. But it's hard to test. Quantum consciousness excites, tying to cosmology, but lacks solid proof. Microtubules are a stretch. Myths and near-death experiences, like those reported in a 2023 Lancet study, hint at a soul surviving brain death. But they're anecdotal. The neural view leads, yet gaps invite wilder ideas. Like a cosmic or quantum thread, this mystery weaves into our series. Consciousness might explain Fermi's silence. Aliens could be non-conscious entities. Per our Fermi outline. It ties to life's origin. Is awareness the spark's next step? Black holes, storing information, might encode consciousness. Per our black hole script, parallel universes could host other yous, their thoughts bleeding into dreams. As our multiverse outline suggests, dark matter's gravity-shaped brains. Dark energy's push sets the stage. The universe's end questions if consciousness persists. Its shape, flat or looped, frames the arena of our minds. The stakes are profound. If consciousness is neural, we're biological machines. Mortal and local. If dimensional or quantum, we're woven into the cosmos, maybe eternal. If dreams or déjà vu, as your Gutmar hints, are cosmic signals. Consciousness bridges physics and soul. Self and universe. Testing this is tough. Brain-computer interfaces, like Neuralink's 2024 trials. Map neural correlates. Quantum experiments, like those at CERN. Probe subatomic links. Meditation studies, like 2021 Yale fMRI scans, show altered awareness states, yet the core why we feel eludes us. Stand in this mirror. Your eye is a neuron's hum, a quantum dance, or a soul's echo. Experiments, fMRI, implants. Microtubules light the path, but the spark stays dark. Are your thoughts yours alone, or ripples from a cosmic sea? Consciousness isn't just awareness, it's the universe knowing itself. Keep questioning. The answer might not be in your head, but in the stars. The universe didn't give us all the answers. It gave us questions, endless, haunting, beautiful questions. And maybe that's the point. From Mars to the moon, black holes to consciousness. What if the truth isn't out there, but inside the mystery itself? If any of these questions stirred your curiosity, drop your thoughts in the comments. No theory is too wild in a world this strange. Whether it's science, spirit, or something we've yet to imagine, your voice matters. And if you found this journey fascinating, don't forget to subscribe. It's one small click for you. But who knows, maybe a giant leap toward truth, luck, and unexpected blessings. Thanks for watching. Until next time, stay curious, stay bold, and may the mysteries bring you fortune.